type. That's why I'm doing it with you. All right, January 2018 exam. All right, here we go. I'm doing this with you because you can't store anything on this one. Can't store any random numbers in. And this is not your typical XYZ problem. Here's why. Look at every equation. How many variables are in each? Only 2. Yeah, this is not XYZ in every one. So I'm going to open it up to you. I got to get to Z somehow. How? Any thoughts right off the bat? How I can get to getting Z by itself? Let's dig deep. Because you're not going to get to it right away. Go ahead, Jason. Let's go. I like it. Good start. Take this, y equals negative 2x plus 14, and plug it in for y into the third equation. But be careful, y. That negative, hey, this is what we're actually doing. Ready? 3x minus that entire thing. Negative 2x plus 14. Okay, watch it. Watch it. Yep. So now it's going to be plus 2x and minus 14. Watch out for that, because I can guarantee that choice there, if you did it wrong, is there somewhere, I bet. All right, let's get x. 5x equals 30. So the value of x is 6, but I need z. Keep trucking. Keep trucking. What do I do with that 6 now? Plug it into the second equation. 3x minus 4 times 6 equals 2. I did something wrong. Yeah, calm down. No excuses. Messed that one up. So I have negative 4z equals negative 16. My value of z, 4 spot. Good start to today. Good start. Anything you want to ask there? So not your typical can't store any number in, unfortunately. And it's not your typical XYZ problem. So, all right, going right to the next one on today, number 4. I'll let you read through that about Utica. All right, so nearest 10th, how many hours of daylight on February 14th? What's X represent again? Number of days since when? January 1st. So here's what I'm asking you. January 1st to February 14th. How many days are we talking about? And hey, I've done this problem a couple different ways. It's okay if you don't know exactly how many days in January, but does anybody know the exact number? 31 days. If you said 30, it wouldn't affect your answer. So I got 31 days in January, another 14 in February. So 31 and 14, what am I going to plug in for X here? 45 in for X. Yep. Now, this is the sole reason I picked this problem. You're about to plug into a sine equation. What mode you got to be in? Radians. Yes, this is the only. Hey, guys, honest, if you're in degrees, your answer's up there, but it's incorrect. All right, your answer will be up there if you leave your calculator in degree for some reason. All right, if you're plugging into a sine or cosine, it's got to be into radian mode. So go ahead, store in 45 for X and plug it into the equation. What is our plan the day of the exam? We sure about this? Okay, one that you're going to know how to use and not just be like, hey, what's going on with this? Okay, I got to know. So when you store 45 in for X, we're looking at 10.4. Yep. For some reason you forget and your calculator's in degree mode, yeah, it would have been 12.1 or 12.2, somewhere in there. And again, if you thought it was 30 days in January, it still would have came out to be 10.4. All right. Questions from you guys? All right, let's keep trucking. Oh, probably shouldn't solve. Yep, there you go. Number 7. I just want you to identify the key phrase in there that's going to help us solve this problem as you read through it. Key phrase that I know exactly where to go. Anybody see it yet? Normally distributed. Ding, 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 ding. That tells me where am I going on the calc? Normal CDF. How do I get there? A little refresh. How do I get to normal CDF? Second vars. Choice 2. All right, we got to pull it in up. So let's read the problem a little more carefully now. I need students who earn a grade less than or equal to 64.9. Less than or equal to 64.9. So what should be my lower bound? Less than or equal to 60. So 64.9 or less. -1. E to the 99 should be the lower one. Remember the E? Take a look again right above the 7. Sorry, right above the comma. -1 E 99. How about your upper value? 64.9. Anybody remember what that was right there, the U? Mean, what's the mean here? 79. And then this value, the O, standard deviation, 7, just 7. Paste that beast in there. Okay, let's talk about this number that I just got out. That's not how many kids. That's what we're looking for. That's not how many kids. This is the percent as a decimal that got below 64.9. How many kids are in the high school? 440, right? So what should I be doing with the 440 and that number? Multiplying both of them to find out how many total kids. So 0.02. $198,97029. So about how many kids? About 10 kids. If this is a non-multiple choice question, remember the work you show is normal CDF, -1 E 99, 64.9, 79.7. Okay? That's the work you show if it's not a multiple choice. Questions from you guys? 15. All right, I got a unit circle. And I'm looking for, what's that again, abbreviation for? Anybody remember that was abbreviation for? Secant. Yes, all right. Before I reveal it, anything you remember about secant? I'm glad you don't remember because I'm going to force you to go to the formula sheet you don't get. Open it up. It's in there. Sorry. It's in there. Find it. Secant is equal to 1 over, find it. It's on the first page. 1 over cosine. Yeah, secant is 1 over cosine. Everyone see where that is? First page, bottom left. Ooh, where can I get cosine from, though? Hey. What circle am I on? Unit circle. Dig deep for this guy. Dig deep. The x-coordinate represents something. The y-coordinate represents something on the unit circle. Anything. Except for silence. cosine is the x-coordinate on the unit circle. Sine is the y-coordinate, only if we're on the unit circle. So on this one, I want to take 1 over, which coordinate do I want? 1 over negative 1/3. That's the value of secant here. And then I'll let you guys do that computation. -3. Okay. Leave that sheet out. It's not going anywhere. All right, so secant 1 over cosine. Whew, a lot of stuff here, huh? Yeah, how about we go part 2, number 29. Let's go part 2. All right, nice. We got 2 different animals here, huh? Rabbits and foxes. When are they going to be both equal in population? Okay. All right, so we got the rabbits and we got the foxes. But guys, there's a you might not know where it is, but there's a key term up here that tells me what equation I need to use here. And that is right here. Take a look. They grew continuously. If you take a look on your formula sheet that you're not given, you will see what formula I need anytime it's growing or compounded continuously. Take a look, please. Take a look. Continuously. Growing or compounded continuously. Nice job. Some of you are finding it. It's the old PERT, right? Anytime I'm doing anything continuously, the old PERT. And I want to know when they're equal to each other. Okay, can you help me fill it in? Rabbits first. What should I plug in for P? How many rabbits are there at first? There are 20 rabbits. E is E. Again, that's the button right above the division sign. That's a number. Leave it E. What's the rate for the rabbits? 5%, but what are you plugging in? 0.05. And we're going to see when time is equal to the foxes. How many foxes initially? 30. E stays E. The rate's 3%, so I'm going to plug in 0.03 T. Oh boy, we got to solve that for T, huh? So I can see when they're both the same. I have no idea. I have no idea how to solve that. First thing I see, the T's in the exponent, right? So it's probably going to be logs. But if I move the 30 over, then whatever that is, I need to get rid of, and I'm just going back and forth. I'm never going to get the E and the T all by itself. So I had no idea. But how can this help me to figure out when those 2 equations are equal without storing random numbers in? I don't have time to guess and check. One more time. I can graph both, can I? And where's the point on the graph where they'll be equal? Where are they? Yeah, let's do it. Let's do it. You think it's that easy, but it's not going to be. Ian, we're going to run into a problem. So everyone, let's go to the calcs. Yeah. Let's graph both of these. Y1, Y2. A little chilly out today, huh? 21 degrees right now. But it's supposed to get warmer overnight. Go figure. Okay, so here you go. I got a graph just like you, and then I hit the graph. Then I hit my graph button, and I don't see a darn thing. I don't see a darn thing. But that doesn't mean, hey, that doesn't mean you graphed it incorrectly. That just doesn't, all that means, guys, it doesn't fit on your 10 by 10 window. So what I would suggest now is go to your table of values now. Okay? Start scrolling up or down here till you see about where they start equaling each other. Go ahead, find that spot for me right now. Bless you. Find that spot where they're about almost equal to each other and we can talk. What's your deal? Yours too? You got these all correct, yes? You're using the E button above the division, not the letter E above sign. One job. One job. Better? You're using the E button above the division? Okay, can we use that, please? Okay, so everyone, are we all at the table? Can you find where they'll be about equal to each other? Anybody give me a number around what number they'll be about equal? What? About 20, right? But I need nearest 10th. And we're not going to guess, oh, I'm feeling lucky. It might be 20.8. No, I want exactly here. Okay? So can you help me change my window so I can see where there maybe intersect? Because a 10 by 10 doesn't do it. So everyone right now, look at these X values right now. What do you think's good X values to go from? Just look at the X values. What do you think will be a good X value to change my window to? 18 to 23. All right, you got it. Hopefully it works, Langston. If not, we're going to blame it on you. 18 to 23. Feel like that's like a survey or something. 18 to 23. And then look at your Y's now. Look at your Y's on the table. What's a good Y values to go to? 50 to 59. All right, I'll try it. And what's the worst that could happen? I don't see them intersect, and I got to go back and revise it. Big deal. You're there for 2 hours. You have to be. So 50 to 59. Let's see if this works. If not, I'm going to blame it on somebody. Oh, there's the one. Yeah, way to go, everybody. Way to go. What? Oh, yeah, all you. Miss, I'm going to take all the credit now. Yep. Shouldn't you be out chopping trees? All right, here we go. A little lumberjack action over there. All right. That's great, but how do I find the point that they intersect at? Second trace. Number 5, intersect. Move that little cursor, that spider boy girl, right over there. Right on top. Enter first curve, enter second curve. Yes. All right. So 20.273255, but I have to round it to the nearest 10th. So I'm going to write down that T equals 20.3. Yes. Okay. You didn't show me any work how you got that. You didn't show me any work how you got the value of T. You just sprung it on, and we're going to assume you just have good eyesight. Okay. What do I need to tell you? Well, on the graphing calculator. And who told me where to go to? Somebody told me where to go to. Like, you don't have to do all the window stuff we did. Graphed on the graphing calculator, went to where? Second trace, intersect. And guys, again, this is only if you don't show, algebraically how you got that value. If all of a sudden you just popped out a value, tell us how you got it. That's all we're asking. Good? Okay, I have one more to do with you, but I need your 100% focus on this one because you've never done these type of problems at all. Okay, this is something brand new I'm going to show you, but it can all be done on the calculator. And the reason why you've never done it is because it never fit into any of the units, but don't get too worried that you missed an entire unit. You didn't. Number 26. Your calculator is going to do all the work. Okay, so something about a runner. They give us a column for A, a column for D. Based on this data, write A. Okay, here we go, everyone. Exponential regression. Please do not get freaked out. Your calculator is going to do all the work. First thing you need to do, wild guess where all these numbers are going to go. Into a list. You got the first half taken care of. So somebody remind me, I've never been in this class before. That's your dream. How do I get to a list? Second stat. Stat, edit. If something's in there, clear it out by highlighting the list and pressing clear enter. So go ahead, list 1, list 2. If it's changing your fractions into decimals, perfectly fine, no big deal. So put it into a list. Make sure your lists match up. One's not bigger than another. Exponential regressions. And I'm just going to wait till everybody's done because it's important here so we all know where we're going next. Okay, we all good? Everyone's got it typed in. Okay, where do I go to get this exponential regression? You hit your stat button again. So go to stat, and you want to go over to calculate. Remember in our stat unit, we just hung out right here at one var stats, but I'm going to see something new now. Everyone see where it says REG every time? These are all the different regressions that we could have the calculator to do. I do not see exponential here because there's more options down below. Now do you see exponential? EXP? Everyone see EXP there? That's exponential regression. So I want to choose that choice. And now up will come X list, Y list. You've only put it in list 1 and list 2, right? Everyone's got 1 and 2. If you got it in 3 and 4, put that in there now. Everything else should be blank. There's no need for any other list other than list 1, list 2. Go ahead, calculate now. Does anybody have more than A and B on theirs? Anybody have an R value on theirs? This is it, A and B? Perfect. Okay. This is how I'm going to write it. And all I'm going to do is substitute in the A value and the B value. Round it to whatever the Regents tells you to round to. All right, so the equation here is going to be, go back to the tests, y equals, what the A value rounded to, what's thousandth mean again? Nearest thousandth, how many numbers after the decimal? 3, so look at the fourth number right now. Y equals, what is your A value rounded to the nearest thousandth? 1.223. Ready? Look at the calculator. Times. Now you can put the times or you can put a parenthesis. It's up to you. You can put the multiplication symbol. The b value, what's the b value rounded to the nearest thousandth? 2.652. And the calculator says raise it to the x. So I'm just going to put raise to the x. It's 2 free points right there, Liz. 2 free points. Guys, the last couple of years, all I've seen is exponential regressions. That's it. That's all I've seen. Do not try to be a hero and multiply those. You cannot. You cannot multiply those two. This is it right here. Done. 2 points. Thank you very much. Next problem, please. Questions? All right, you're on your own for the rest of class. Let's go. I got 5 problems for you to do. Chromebooks, open them up. Here we go. Open them up. Get the answer keys going. 27, I don't care what order you go in either. 27, 9, 10, 16, 19. And you got